Hi. Okay, once again, it's our TASMO sample paper walkthrough. Okay, good to see everyone here again. We will start punctually at 5:30 p.m. Right, so we are actually moving on to the last week before TASMO deadline for registration. Okay, if you have not registered for TASMO yet, please scan this QR code below and register for P2 TASMO 2025 by August 31st. Right, we have three locations to choose from: Tai Seng, Marine Parade, Buona Vista. Right, and if you see Tai Seng and Buona Vista in orange, that's because the slots at these two centers are very limited. Okay, so please make sure if you want to secure the slots at these locations to act fast, okay, and secure your slot. So today we are doing sample paper 5, okay, pretty much easier than the rest of the 4 papers, right? I have collected some statistics and it seems that most of you are doing pretty well, right? So yeah, today we'll just go through some challenging problems as usual. So we will wait for 2 more minutes, two more minutes, right, before we start. Hello, okay, I see more and more people in the chat. Right, by the way, someone asked, right, what is a team registration? Okay, so you can also register to join us as a team, right, to win extra prizes on top of individual prizes, right? So here is some information. Okay, please complete the team registration by 31st August as well. And yeah, we shall talk about this further once we start the live stream. All right, in 1 more minute. All right, let's get started. It's 5:30 now. Hello, welcome. Okay, so it's our fifth sample paper live stream for P2 TASMO. Right, so as usual, we will be going through some challenging problems in this paper today. Okay, so if you have yet to register for P2 TASMO 2025, please take note, okay, our deadline is in August 31st. Make sure to secure your slot at Tai Seng, Marine Parade, or Buona Vista, right, to join this competition. In particular, our availability at Tai Seng and Buona Vista is more limited. Okay, so if you are more interested or if you prefer these locations, please make sure to secure your slot by scanning the QR code shown in the screen here. Okay, and besides that, right, we have also introduced the team category. So if you register for our competition, right, by default, you will be joining our individual category and stand a chance to win individual prizes. But you can also form a team of 3 students of the same grade level, right? Form a team and then just create a group chat with our admin teacher or just me actually, right? To register as a team and win extra prizes on top of individual prizes. There is no separate contest for the team category. You sit for one paper and we will calculate the total scores of your 3 team members and then award a team prize if it hits a certain threshold. Right, similar to individual registration, right, the team registration is to be completed by 31st August 2025. Right, so if you know some friends in your school or in other centers that perhaps are also interested in our TASMO competition, please invite them to join this event as well. And then you can form your team to win double the prize with just one single paper. what are the prizes, right? So for team awards, right? Again, in addition to individual awards, so team awards and individual awards are stackable, right? They are given based on the total score, right? Depending on where your total score is at for your 3 members, you may be awarded some cash prizes or our exclusive basketball merchandise, right? So if you are interested, please join as a team, right? Invite your friends and come together. All right, so again, we have received a lot of submissions today, right, for sample paper 5. Thank you so much for everyone's consistent effort. I see familiar names appearing since sample paper 1 to sample paper 5. Right, good job, everybody. Hopefully, as the competition gets nearer, right, your hard work will all blossom into success. Okay, so regarding this paper, I would also want to praise everyone, right? Very good, right? Because I see some huge improvement in the scores, right? In particular, 50th and the 75th percentile is all very high, right? And most of the questions, actually, you see the accuracy rate is already pretty high compared to usual. That being said, there is still some pretty challenging problems in section B, right, which is exclusively catered by me. Okay, so I'll go through these questions today. Today, teacher Yonglam will be a bit ambitious and try to go through 9 problems, right, perhaps 10. Yeah, hopefully it will be a lesson jam-packed with useful information for the competition as well. And without further ado, let's get started with our first question of the day, which is section A, question 4. Now, question 4 is actually very straightforward, right? Just that perhaps the words, right, may not be expressed as per usual. So let's read the question. We want to subtract 4 from each positive multiple of 10 that is less than 100. How many of the results obtained are not multiples of 3? Right? So this question, we start off with positive multiples of 10. Now, positive multiples of 10 means it is greater than 0. It starts from 1, right? And we want it to be less than 100. Now, a lot of the kids might get confused or might miss out on this point. We want multiples that are less than 100. So let's start off with step 1, which is by listing out the relevant multiples of 10. We want positive multiples of 10, so it cannot be 0, right? And it is less than 100. What are these multiples? Can you list them out for me? Right, we have 10, 20, 30, 40, 50, 60, 70, 80, 90. Is there 100? There is no 100, right? I want less than 100, right? So moving on into the competition, it's important to realize and to understand what the question actually means, right? Less than, not more than. What is the difference between that? By less than 100, I do not include 100, right? But we don't stop here because we want to subtract 4 from each of these multiples. So let's just subtract 4 from each of them and see what we can get, right? So for example, 10 minus 4 is equal to 6. 20 minus 4 is 16. 30 minus 4, 26. By this point, you can list out everything, and some kids will already realize, yes, 6, 16, 26, all the way up to, I know, 96. Do I want 96? Right, again, I don't want 96 because I have the largest multiple that I want being 90, and 90 minus 4 is equal to 86. I do not include 100, right? So I just stop at 90. Therefore, after subtracting by 4, I stop at 86, right? And then I am asking you, how many of the results are not multiples of 3? So which of these results ending with 6 are not multiples of 3, right? So if you have done this step, the final step is just to check, right, which of the results are not divisible by 3. Now we start from the first one, 6. 6 is a multiple of 3, so bye-bye, I don't consider it, right? 16, yes, it is not a multiple of 3, so I will keep it. 26, also not a multiple of 3. 36 divided by 3 is 12, right? 12 times 3 is 36, so I don't want it. I just want to keep those that are not multiples of 3, such as 46 is not a multiple of 3, 56 also, okay? And then when we move on to 66, 66 is also not a multiple of 3, so I exclude it, okay? And then for 76, not a multiple of 3, so I keep it. 86 also not a multiple of 3. I will keep it. So with that, we have listed out all the results and how many of them are not divisible by 3, right? We have 2, 4, 6, right? So answer is D, right? I see in the chat someone said, wow, very easy this question. Of course, right? It's because you read the question carefully, you understood what it said, you did not fall into teacher Yonglan's traps, right? This paper is actually not that difficult, just that there's a lot of traps to remind everyone to be more careful when attempting your problems. All right, so that is it for question 4. When it comes to multiple type of question, sometimes you might want to list, sometimes you might find out how many multiples of something are there in a certain range. So these have specific ways to do it. Please make sure you master them. All right. And moving on, we can go to question 7, which is a queuing problem. Now, this question for my fellow MHA kids, right, it is from your term 2, lesson 10, right? So hopefully you still remember how to attempt these such questions. Now, let's read the question. We have some students, including Alice and Bob, are queuing up outside the classroom. Alice is the 19th student counting from the front to the back of the queue. Bob is the 15th student counting from the back to the front. So there are 2 main characters, Alice and Bob. And the question said Bob is in front of Alice and there are 5 students between them. Now, so where Bob is in front of Alice. Now, actually, your thought process is half correct, right? When it comes to queuing problems with double main characters, it might sometimes be confusing like this. But by following the following SOP, right, we can solve this problem easily, right? The question is asking how many students are there in queue. So step 1, we always identify the directions of the queue first, right? So here we have the front and the back, so we label such directions, right? Students might think, hey, this is such an easy detail. Queues are of course from the front to the back, but let me tell you, listing them out will prevent you from using the wrong direction later. Right, so these sort of problem-solving details might be what differentiates from getting a silver medal to getting a gold medal, for example. Right, so please be extra careful regardless of how easy this question is. Right, so simply list up the directions first, and now we will start from the main characters. Right, there are 2 main characters in this question, Bob and Alice, and as mentioned by the question, right, Bob is in front of Alice. So I will draw Bob near the front. And then, haha, I know I draw Alice here. Can I draw Alice like that? Can I draw Alice right behind Bob? Tell me in the chat. Did teacher Yonglam do this correct? Oh, no, of course not, right? Because the question already said there are 5 students between them, right? 5 students between them. So we have to leave a gap between Bob and Alice and include the 5 students between them. So 1, 2, 3, 4, 5, 5 students, right? And then please take note that this queue doesn't start from Bob and with Alice, right? Because if we want to count, there's definitely more people in front of Alice. In fact, Alice is the 19th from the front. So there's some people in the front. There are also some people at the back. So with this drawing, we completed the queue, right? So start from the main characters, then the people in between, and then there are some people in front and at the back. Okay, and now here is where the numbers come into play, right? We need to label the numbers using benches or brackets, if you like, right? So this is what we also call the bench method in MHA. Now, what numbers did the question give? Let's revisit it. The question said Alice is the 19th from the front. So from the front. Now, here is where it's important. You have to look at the front and then start from the first person all the way to including Alice, right? So in this case, starting from the front, if I count, by the time I count until Alice, how many people have I counted? By the time I have counted Alice, I would have counted 19 people, right? Because Alice is the 19th. Alice is the 19th, so there are 18 students in front of her. Right? That is from the front to the back. Likewise, the question also said Bob is the 15th student counting from the back to the front. Right, so if Bob is in front of Alice, right, that is what we have learned just now. But counting from the back to the front, this time we count from the back and go all the way. If we keep on counting, oh, very ugly. If we keep on counting, right, by the time we reach Bob, how many people are there, right? So we can draw out the bench, perhaps a bit more neatly, right? Bob is the 15th counting from the back, so it's 15. All right, and now, how many people are there in the queue? I know, 19 plus 15. Done. Okay, E, none of the above. But look at the picture carefully. Is it really 19 plus 15? Or have we double counted some people? Is there some overlap? Did we count some of the people more than once? How many people did we count more than once? We counted all the way from Bob to Alice, right? All of these people here have been counted more than once, right? They are included in my 19. They are also included in my 15, right? So to prevent this double counting, what I would do is to minus away how many people did we double count. So there was Bob, one person, Alice, one person, and 5 people between them. So altogether, -7 because I have to remove the double counting for 7 people. And then we perform this calculation and you will get 27 people. There are 27 students in the queue. Right? The answer is A. Right. Alternatively, you can also just find out, I have 90 students here already. How many students are here that are not included in the 19? Right, so you are basically doing the same thing, 15 minus 7, right? They both give you the same result. Okay, so when it comes to queuing problems, just draw a picture and visualize everything clearly. Then it should be all good. All right, is everything okay? Can I move on to the next question? Okay, let's continue with the next question, which is on question 12, right? Counting 2D shapes. I remember last week's paper, we also talked about counting squares. They are just of different sizes and orientation, right? So this is just what I want to remind you. Whenever we are counting squares, just like here, there are how many squares in the diagram. Make sure to count by the size and the orientation. Size from small to big. Orientation, whether it is upright or it is slanted, right? Good news for you, there aren't actually any slanted squares in this picture. However, counting by size is going to require a bit more eye detail, right? You need to pay a bit more attention because usually, right, in counting squares, the easy type of question will just give you a grid, right? All the squares are performed in the form of a grid, right? But sometimes the question might be a bit sneaky, right? For example, what if I remove the lines in the middle? Then some people might not immediately realize that, oh, this is also a square. So you need to pay attention to the sides, right? These details in the case that some of the grid lines are not given. Okay, so let me erase this and then we can move on to counting. Right, so again, we count by square size and orientation of the squares. No tilted squares, only outright squares. So can you tell me how many 1-unit squares are there? We start from small to big. How many teeny tiny small squares do you see? Right, they are the easiest to spot. How many are there? How many teeny tiny squares? I see 1. Right, any more? How many teeny tiny squares of this size are there? Okay. Yes, very good job. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 1-unit squares. 8 of them here. Okay, let me use a darker pen. Let me use a darker pen to highlight it. Give me a moment. Yes, I have 8 1-unit squares, right? 1, 2, 3, 4, 5, 6, 7, 8. And then now we move on to bigger squares, right? My 2-unit squares. Now, some people might say, teacher, there's only one 2-unit square, what? It's over here, right? This is the most obvious 2-unit square. That's good, you identified one. But is that the only one? Now, what about this one? Is this a square? Right, this is also a square, in particular a 2 unit by 2 unit square. So we also need to count it, right? And this one as well, yeah, it's also a 2 unit by 2 unit square. Then there's the middle one, which I guess most of you have found. And then on the right, there is a similar one. Below, there's another one. So in total, I will have 5 2 unit squares. So sometimes you just need to be paying more attention to the outline of the squares, right? Size by size, small to big. Okay, look at the outlines carefully. There are some that might not appear in an obvious grid manner, right? So you need to pay extra attention. Okay, now let's continue with the 3 unit square, right? How many 3 unit squares are there? Again, pay attention to the outline, right? If you pay enough attention, okay, hopefully you have been circling it, okay, and noticing it by now. This is a 3 unit square, right? It's bigger, but not the biggest, right? It's 3 unit by 3 unit, right? So 3 unit by 3 unit, 1 of it, 2 of it, okay, and then 3 of it, 4 of it, all the corners, they have such a 3 unit square. So there are 4 3 unit squares. Okay, and finally, last but not least, we have the biggest square ever, which is basically the entire figure. Right, this entire figure is a 4 unit square, right? The biggest square ever. So I have one more square. Okay, and with that, you just need to add the numbers up. 8 plus 5 plus 4 plus 1 is equal to 18. So I will have 18 squares in this diagram altogether. Okay, so the key point here is sometimes the question might be a bit evil. Okay, they might not give you the entire grid, right? You have to spot the outline of the shapes itself, in particular those medium-sized ones, right? Some of them could be hidden quite well. So check the outlines. Okay, so yeah, that's it for question 12. Hopefully it has been very mind-blowing so far. Okay, and then let's take a look at question 14. Aha, calendar problem. Once again, our good old friend. Right, it seems like calendar problem is one of the most challenging topics, whether being it's TASMO or TASMO. Right, so today teacher Yonglam just want to share with you a trick when you see weird calendar problems like this. Right, so let's read the question first. The question says that suppose the first day of a month is Friday. I don't know what month it is. It is just a certain month. Which of the following statements is impossible? Right, so among all these 5 very similar choices, right, we have one of them that is definitely impossible to happen. The first day of the next month could be a Saturday. The last day of the same month could be a Sunday. The first day of the next month could be a Sunday. The last day of the same month could be a Monday. The first day of the next month could be a Monday. Oh my God, they all look so similar, right? But what are they talking about? Right, we are analyzing what are the possible last day of the month and also the first day of the next month, which is possible, which is impossible. So basically, everything is boiled down into searching for 2 things, right? Number 1, what is the possible first day of the next month? Number 2, what is the possible last day of the same month? So when it comes to calendar problems like this, where we are given weird descriptions about a certain month, my advice to you is to just draw out the calendar and visualize it, right? I remember I have gone through this in my SASMO prep as well. Whenever you see the question says a certain month has what start, what end, etc., draw it out, visualize it clearly. Right. So for example, in the calendar, you see that there is usually a header for the month, but we don't know what month it is. It could be any random month. So we just leave it as it is first. But I know the first day of a month is a Friday. So we can draw out the headings representing the days of the week, starting from Friday. Okay, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday. Now, I don't need to continue with Friday because if you remember a calendar, by the time we enter the next week, we just move on to the next row. Now, why do I put my Friday here? That's because we know, right, the days in a month also go week by week. So I can include full weeks over here. For example, this is 1 full week. Right. Now, before you blindly draw out everything, okay, Please remember, this month doesn't specify how many days it has, right? So my question to you, how many days could this month have? I don't tell you anything, right? I just told you it is a random month, right? It's a random month. Oh, you use different methods. Okay, as long as you get the correct answer, good, go ahead. Okay, how many days could this month have? A random month, any month. What are the possible number of days that this month could have? What are the possible number of days that this month could have, right? So people might say, yeah, 31, right? 10, 30, 10, 28. Did you miss something? Is it always 31, 30, or 28? No, right? In the very special case, on leap years, right? February has 29 days. So it could be 31, 30, 29, or 28 days, right? So let me retract this pop-up. It could be that this month has 31 days, or rather, let me just go from small to big lah, okay? At least this month will have 28 days, or it will have 29 days, or it will have 30 days, or it would have 31 days. So there are actually 4 cases that you need to consider. This month possibly has 28, 29, 30, or 31 days. And in each scenario, we want to find out what is the first day of the next month, what is the last day of the same month. So let's start off with 28 days, right? It's the easiest to draw because we know that 28 divided by 7 is equal to 4, right? That means if my month has 28 days, it will just be 1, 2, 3, 4. 4 full weeks. Okay? So if my month has 28 days and it starts on a Friday, because it has 4 full weeks, you see, once you draw this out, it's pretty clear, right? What is the last day of this month? What could be the last day of this month with 28 days? What is it? It's a Thursday, right? So my last day of this month could be a Thursday. Then what is the next day of which is the first day of the next month? This month, my last day is a Thursday. Tomorrow, the next day, will enter the first day of the next month, which will be a Friday, right? Because I'm at the last day of this month already. Then the next day, which will be the first day of the next month, right? It will be one day later. So the day after Thursday will be Friday. Possible, okay? But then you see, none of the options fulfill what I'm saying here. It's okay, let's just continue. What if this month has 29 days, right? Once in a leap year, right? What if it has 29 days? Then my 29th will be a Friday, which means the last day of this month will be a Friday. And what is the first day of the next month? Again, one day later, the first day of the next month could be a Saturday. And at this point, you realize, yes, I can finally cancel out. A is possible, so A is not my answer. The first day of the next month could be a Saturday, right? Provided that this month has 29 days. But it seems like I still have 4 options to eliminate. Then let's move on to the next case, right? What if my month has 30 days? If my month has 30 days, this time, the last day, the 30th, is a Saturday. So the last day of the same month is a Saturday. And the next day of the first day of the next month will be Sunday. Right? Because this month ends on a Saturday, we will start the next month on the next day, which is a Sunday. So here you notice I have Sunday over here. The first day of the next month could be a Sunday. Possible when this month has 30 days, right? So C is possible. It's not what we want. Now let's move on to the final case. Hopefully we can eliminate enough options. Right. What if I have 31 days in this month? Then the last day of this month will be a Sunday. The last day of this month will be a Sunday. And the first day of the next month will be one day later. What comes after a Sunday? It will be a Monday, right? So the last day of the same month could be a Sunday. A, B says so. So B is possible. It's not what I want. The first day of the next month could be a Monday. E said so, right? The first day of the next month could be a Monday. E is what I want. So, sorry, E is possible. So E is, I don't want it, right? I want an impossible statement. So the answer we have is D. The last day of the same month could be a Monday. Impossible. Because if month is 31 days, at most, the last day could be a Sunday. We cannot go further. Right, so with that, my answer is D. Now, this is a bit unorthodox, right, compared to what you usually see in TASMO or SASMO, right? But my point still holds. When the question describes a certain month, it gives you some weird description about 1 month. Draw out the calendar and try to visualize it, right? That's my advice for you in question 14. Okay, so hopefully now you learn a new trick for calendar problems. Okay, with that, we are basically settled for section A. We can move on to section B now. And the first question I want to go through in section B is working backwards for question 19. Right, this question is actually pretty standard. It's considered one of the more manageable word problem topics. Right, just that you need to read the question very carefully and really understand what the story is talking about. What type of mathematical operations, right? Plus, minus, times, divide, are we describing in each step? And most importantly, how many steps there are. So, the tool we will use is to draw a train diagram, right? So, there is a wishing well in the magical land. To make a wish, a person will first need to throw 15 coins into the well, right? So I throw 15 coins first. And as a result, the number of coins he owns will double. Fred visited the wishing well and made 2 wishes. At the end, he had 150 coins. How many coins did Fred own at first? Now, whenever you see a question that tells you, okay, at the end, I have how many? But at the start, I don't know I have how many. Then it's definitely a working backwards question. And 90% of the time, it will solve it using a train diagram to clearly lay out what happened in each step of the story. All right, so let's take a look at the question again, right? We start off with a box to label our starting number. Okay, now to make a wish, a person will first need to throw 15 coins into the well. So reading the question again after identifying that it's a working backwards problem, it's important to make sure you follow the order of the steps, right? I need to throw 15 coins into the well, which means, right, I will have 15 less coins. At first, I will have 15 less coins. I throw away. So it's actually subtraction, minus 15. And as a result, the number of coins he owns will double, right? So double means whatever you have, you now have 2 times of it. So it becomes a times 2, right? So first, the number of coins I have will minus 15, and then I will times 2. This is to make a wish, right? So let's say Fred made a wish. So first, he will throw away 15 coins, and then he will double his amount of coins. And then some students will stop here and say, oh, teacher, I know the answer is 150. And then I just move backwards. Well, I guess everyone is pretty familiar with how to do the calculations for this, right? Everyone is good at calculation. If you don't, it's okay. Take some time to practice. But hey, look at what is hinted here. This process is for 1 wish. But how many wishes did I make? Did I really only make 1 wish? Fred made 2 wishes. So this process is for 1 wish. After that, I will need to repeat it again. I need to minus 15 and then times 2 again. This process is for the next wish to cover 2 wishes in total and finally get 150 coins at the end. Right, so read the question carefully. The details is everywhere. Once you are able to sort out the story and then list out all the steps correctly in correct order, then sure, the calculation part is not that difficult, right? All we need to do is to work backwards, use the opposite operation, okay, or the inverse operation. So, for example, 150 after I double. So we work backwards, right? Before doubling, so I would divide by 2. to get the number of coins. So 150 divided by 2 is 75. Okay, please stop spamming the chat. Okay, I can see you as well. Then he loses 15 to get 75. Then that means at the first he has 75 plus 15 equals to 90. Right. So after the one wish, he has 90. Then after the second wish, he will have 150 coins. Now I need to go back one more time. So let's quickly do that. First, 90, go backwards. Divide by 2 is equal to 45. Then 45 plus 15 is equal to 60. So at the end, I have 60 coins. Or rather, sorry, at the start, I have 60 coins. But at the end refers to, oh, after solving the problem, at the end, you get that the answer is 60 coins. Right, but yes, this is the number of coins at first, right, at the beginning. Now, once you are done, it is advised to check your answers again. 60 minus 15 times 2 minus 15 times 2. Does it get your answer or not? Right, so check your answers very carefully. These sort of problems, right, when it's a single training diagram, single character, it's easy to get it correct, right? But also pretty easy to get it wrong if you don't pay attention. So check your answers thoroughly. Okay, and with that, let's take a look at question 20. All right, question 20 is a divisibility question. And to be honest, teacher Yong Lam made quite some tracks here, right? So here we see that a 5-digit number, 9A1A8. So this means it is a 5-digit number, right? If you see the bar on top, it is a multiple of 3. What is the difference between its largest and smallest possible values? Now, important question, what does this it mean? Its value, right? Its is referring to the 5-digit number. So I want to look at the 5-digit numbers, smallest and largest possible value, and also find out what is the difference between them. Okay, so here the key point is, as usual, what defines a multiple of 3? What defines a multiple of 3? Can you tell me? Right, can you type in the chat? To check if it's a multiple of 3, what do I need to check? Do I check the last digit or do I check the digit whatever? Right, what should I check? Last 1 digit, last 2 digits. Right, some people have prediction. Okay, so please don't spam the chat. Okay, please just type whatever is constructive for the conversation and discussion. Thank you. Right, so as you can see, right, the digit sum should be a multiple of 3. I don't need to do long division. I just need to check, is my digit sum a multiple of 3? If it is, automatically it is a multiple of 3 for the number itself. Right, so basically, I just need to make sure that the digit sum, which is 9 plus a plus 1 plus a plus 8, must be a multiple of 3. Okay, so let's simplify this a bit. We have 2 copies of a, right? So we want 18 plus 2a must be a multiple of 3, right? Because 9 plus 1 plus a is 18. 9 plus 1 plus 8 is 18, and I have 2 copies of a. 18 plus 2a must be a multiple of 3. Now, what are the possible values of a? So you can just list one by one. Does the 2a's have to be the same? Good question. Now, if the letter is the same, then it will refer to the same number, same digit. However, if it comes out like this, blank, blank, right? For example, I give you the blank like this, okay? Then actually, these 2 blanks may be different digits. But if I use the same letter, then it will be the same digit. Okay, but actually, I think this doesn't matter in the question. Okay, anyway, what are the possible values of a? You just need to list one by one, right? But don't forget, here, a is not at the highest place. So a could be 0, right? A lot of kids also missed out on this one. A could be 0. If this digit is not at the highest place, then it could be 0. But if I put a at the highest place, then you don't start from 0, start from 1. Okay, when a is equal to 0, then the digit sum is 18 plus 2a is equal to 18, which is a multiple of 3, right? So a can be 0. Now, the next one will be a equal to 3. Hint, usually you will jump 3 by 3, right? So a is equal to 1, cannot. 2 cannot. 3 can, because the digit sum 18 plus 2a will be equal to 24. Possible. The next one, again, usually we jump 3 by 3. Okay, so the next one will be a is equal to 6. A is equal to 6. 18 plus 2a is equal to 30, right? This is possible. Okay, and then what is the next possible case? Okay, so we have a equals to 9. 18 plus 2a is equal to 36. Possible. So a could be 0, a could be 3, 6, or 9. Now, we want the largest and the smallest possible values of the 5-digit number. Of course, the largest possible value is given when a is the largest digit. So we have 99198. This is the largest possible value. And the smallest possible value, the other digits are fixed. So let's just make a as small as possible. So, you skip 15, 16, 17, 18. Oh, that's because I have already mentioned at the start, right? What other questions I'll go through, right? So 90108, and then small. Then I just need to subtract it, okay? And do your calculations carefully, okay? 0, 9, 0, 9, 0. Okay, so my answer is 9090. That's my difference of the 5-digit number. Okay, so yeah, for this question, when it comes to multiples of 3, multiples of 9, some students might forget, oh, I can actually consider 0 if my unknown digit is at the right, and it's not at the highest place value. Okay, so always pay attention to when I can use 0. Okay, as for some kids who said, hey, you skip some of the questions. Yeah, usually I will select the questions that are most challenging for the students. Okay, I will send the solutions to the group chat later so that you can refer to the explanations for all the problems. Okay, right, so moving on, we have question 23, right? It's a comparison and replacement problem, right? We have Yusuf spent $88 to buy a hat and a pair of shoes from a clothing store, right? $88 for a hat and a pair of shoes. Isha spent $464 to buy 3 hats and 7 such pairs of shoes. How many more dollars does a pair of shoes cost compared to a hat? Right, so we have 2 things, hats and shoes, right? And 2 buying scenarios. So we want to find out what is the price for each of these items. So with that, maybe, right, reading a bunch of words is pretty brain teasing, right? It will make your mind blow off. So it's okay. We can use some math symbols to simplify this, right? And write it in another equation form. Right, so what we can do is we compare the 2 scenarios. Yusuf bought how, Isha bought how, and we want to find the extra amounts coming from some extra items. Okay, right, please excuse me. All right, apologies for the little hiccup there. Now, we want to compare the 2 scenarios. Yusuf how, Isha how, right? So let's give us some symbols, right? You can draw hats or draw shoes to help you understand it better, or you can just let H to represent 1 hat, S to represent 1 pair of shoes. Then we analyze the 2 scenarios again, right? For example, from Yusuf's scenario, a pair of hats and a hat and a pair of shoes, H plus S is $88, right? Given by the first scenario. The second scenario says 3 such hats and 7 such pairs of shoes is $464. So 3H plus 7S is 464. Yes. Now with that, we want to see what is extra. But then you see, here I have more hats and more shoes as well, right? Usually, if an equation has 2 unknowns, it's pretty hard to solve. So we try to force out an equation with only 1 unknown. Now, Yusuf only bought 1 hat and 1 pair of shoes. I think he bought a bit less. What happens if he bought 3 hats and 3 pairs of shoes, right? So 3 hats and 3 pairs of shoes, that's 3 sets of whatever he's buying here. 3 sets. So we use the first set multiplied by 3, right? And that will give me 88 times 3, which is equal to 264. So with that, we can now compare, right? 3 hats and 7 shoes is 464. 3 hats and 3 shoes, they add up to 264. What is the difference? Why do they cost the different number of money? Right, stop spamming in the chat, please. Okay? Why? Why is the amount different? Now that is because there are 4 extra pairs of shoes. If I compare the second scenario and the third scenario, 7 pairs of shoes versus 3 pairs of shoes. I will have an extra 4 pairs of shoes. 7 minus 3 is 4. So how much money does these 4 extra pairs of shoes cost? It will be 464 minus 264, right? Because you realize the hats are the same, just that I have 4 extra pairs of shoes. The extra money must come from the 4 shoes. So 4 shoes is 464 minus 264, and you realize, hey, it's a pretty number, it's 200. So with that, 1 pair of shoes will be 200 divided by 4, which is $50, right? So by now, some students will be very, very rushed, right? They'll say, okay, answer 50. That's why you have to reread the question again. The question is asking how much more dollars does a pair of shoes cost compared to a hat? So we are asking shoes and hat, what's the difference in their prices? So we can't just stop at finding the shoes price, we also need to find the hat's price. Now here's another tip though. I have so many ways to find the hat's price. Which equation or which relationship, which scenario should I use to find this? We usually pick the simpler equation, right? For example, here, the simplest scenario would be the first scenario because 1H and 1S is 88. I tell you X is 50. Definitely you can tell me H is how many, right? The total is 88. So H plus 50, this is 50, is equal to 88. H is equal to 88 minus 50, which is 38, right? And now I just need to find out how many more dollars do I need to buy shoes. So to combine them, $50 minus $38 is equal to $12. And my answer is 12, right? So yeah, that's how I get this question. Okay, it's pretty confusing because the steps might not be as direct as expected, right? But most importantly, you compare the two scenarios. Try to find extra of one type of item. In this case, shoes will be easier. All right, so that is for question 23. Now let's move on to question 24, which is again a good old friend of ours, right? Addition and multiplication principle. Now we see that Alma has 6 number cards as shown in the figure below. Using 4 out of these 6 cards, right? That means I cannot repeat choosing the cards. How many 4-digit even numbers can we form? Right, I want 4-digit even numbers. So as usual, label down the seeds first. Right, so we have 1, 2, 3, 4, 4 seeds. Okay, so hold on a second. Right, apologies. So these 4 digits, right? Because 4-digit numbers, so I gave 4 seeds. So we list out the seeds and think about what are the possibilities to choose for each seed first. Right, so since we want even numbers, of course, the pickiest seed would be the ones place. Right, because the ones digit must be even. So what are the even digits that you can use? What are the even digits that you can use? You can use 0, you can use 2, you can use 4, you can use 8, right? Okay, so now I have selected my even digit. It's 1 of 0, 1 of 2, 1 of 4, 1 of 8, right? So 4 choices, 0, 2, 4, or 8. But hey, remember there's a 0 here. 0 is sus, right? Because like what I said just now, 0 cannot be placed at the highest place value. So then how many ways are there to choose this thousands place digit? How many ways are there? Right. So after selecting the ones digit, how many ways are there to select the thousands digit? You might realize it actually depends. Right. This is the trickiest part of the question. The number of choices I have here depends on what I have chosen for here. Right. Let's imagine for a while. If I choose 2, or I choose 4, or I choose 8 as my ones, then I did not choose 0 as my ones. So let's say, okay, for example, I choose 2 here. I did not have 2 anymore. So how many choices do I have for the thousands digit? I cannot choose 0 because 0 cannot be at the highest place. So it could be 4, 7, 5, or 8. I will have 4 choices here. But what if I choose 0 as my ones digit? I have taken 0. Do I need to consider 0 cannot be at the highest place again? I don't need to. All the remaining 5 digits are non-zero. I can pick any one of them to put at the thousands place. So actually, whether you choose 0 or not will affect what will unfold in future choices. So 0 is extremely sus, right? Extremely dangerous, right? Because it could not be at the highest place. So sometimes you might need to consider cases because where you put 0 first might affect your later choices. So there are 2 cases over here, right? The first case is the very special case. One's digit is 0. If my ones digit is 0, then that means I have selected that one and only choice for my ones digit. So I have taken 0 away. Now, let's look at the thousands place. Do I need to care what digit to put here? I don't need to anymore, right? 4, 7, 2, 5, 8. Any of them I can put at the thousands digit. So there are 5 choices. Then I have taken away one more digit. So for the hundreds place, 4 choices. I have taken yet another choice. So I have 3 digits left to choose for the tens place. So 5, 4, 3, 1. And finally, multiply all their choices. In case 1, you will see that there are 64 digit even numbers that I can form, with the ones digit being 0. Now we can move on to case 2, where my non-zero ones digit is appearing. But then, just because it's not 0 doesn't mean it could be anything, because I want even numbers. So my ones digit could be 2, could be 4, could be 8. Any one of them will give me the same result because I still have 0. So there will be 3 choices for the ones digit. And then now, let's say I selected 2 like just now, right? Then how about the thousands place? How many ways can I select the digit for the thousands place? I have selected one even digit. And I cannot put 0 here. This cannot be 0. So I will have 1, 2, 3, 4. 4 more choices for my digit at the thousands place. Then I will need to choose the hundreds place. At this point, how many digits are left? Now I have selected yet another non-zero digit. Let's say 7 right at the front. But then here, I can still put 0. So essentially, I have already selected 2 digits to put at the ones, at the thousands. Then for the hundreds, I will have 4 more choices. For the tens, 3 more choices. And then I multiply them together. Remember, if I cannot repeat the digits, every time I selected for one place, for the remaining places, I will have one less choice. So 4 times 4 times 3 times 3, 96. 144 choices here. Again, you see, teacher Yong Lam also made a calculation mistake. So be careful. Do your calculations carefully. So what is the total number of numbers I can make? It will be 60 plus 144. So that gives me 204 4-digit even numbers. Right. So whenever you see a forming number question, but with 0, right, you need to pay extra attention because 0 is very dangerous. You need to consider it carefully. Okay, now that is the question 24. Let's move on to question 25, which I believe will be the last question of the day. right? It will be about perimeter of rectangles. And here my advice for you, be careful for extra sides. Now this looks a bit similar to what I taught last week, right? Let's read the question. Two identical small rectangles, important they are identical. Small rectangles have been cut off from a rectangular piece of cardboard to form the figure as shown below, right? It looks like an E lying down, right? This is an E lying down. Oops, I can't go. E. Right. Now each small rectangle removed, oops, I can't go. Each small rectangle removed has a width of 2 cm. So 2 cm, 2 cm. If the total perimeter of these two small rectangles is 36 cm, what is the perimeter of the figure below? So I'm asking for this E, what is its perimeter? Now, let me just show you using some visuals what's actually happening. So the cardboard actually looks like this. But then these two small blue rectangles, they are identical, they are the same. And I will remove them. So yeah, they look like this. And now I want to find the perimeter of the figure, which is this E. Right, so what sides are included in this E? It is this, this, right? Pretty easy, right? It kind of looks like it's a full rectangle, except there are some ups and downs here, right? These sides that I'm taking, they are included in my perimeter. Now take note, although this here says 2 cm, there is actually not a 2 cm side here. These two labels are just telling you the width of the rectangle that I removed is 2 cm. So actually this 2 cm is referring to this length. This length. Right, pretty sneaky, huh? Some of you included this in your perimeter calculation as well, right? Please don't. Now, let's continue with our calculation, right? We know that the total perimeter of these two small rectangles is 36 cm. So that means what would the perimeter of this one small rectangle be? For one small perimeter, the one small rectangle, the perimeter is simply 36 divided by 2, which is 18 cm. So this entire rectangle, the sum of the lengths of its four sides, 2 cm, 2 cm, I don't know how many, is 18 cm. Take note, 36 cm is for two such rectangles. Then we just need to find its length, right? I know the width is 2 cm. And then the length will just be 18 minus 2 because we need to remove the 2 copies of the breadth, and then divided by 2 because after subtracting 2 copies of the breadth, I have 2 lengths. So to find only one length, I will divide by 2. And this will give me 7 cm. Okay, so one length is 7 cm. And with that, now we can find out the figure's perimeter, right? Some of you have been, I think some of you are shouting by your screen now, Teacher Yonglam, this one I can use push-up method. That's right? That's the key of this question. We can actually move some of the sides around to make it look like a regular rectangle. Again, do you remember what's my tip? Before you try to push up the sides, what must you do? You must trace the rectangle, right? So we trace out the rectangle that we want to form. Now we have all these sides here. Okay, pass, everything is here. Also here, yes, every part is filled. Here, every part is filled. But here, you notice that, oh, there are 2 gaps, right? 2 cm, 2 cm. So can I push out some of the sides to the top to make it a full rectangle? Of course I can, right? You see, this part, this horizontal little side, which is like the width, I can push it up to the top and put it here to complete this gap. This part, I can also push it up, right? Push it up and complete this gap. And with that, I have formed the complete rectangle. So the complete rectangle is formed. So the perimeter is 8 plus 9 times 2 for the rectangle. But is that all? Is that all I have? Well, actually not, right? Because don't forget, when you use the push-up method, especially when you see trap shapes, right? You see there's a little trap here, a little hole here. Be careful for your extra sides. Okay, so how many extra sides do you have? Now, which sides did I not push out to the entire rectangle yet? This side, this side, this side, this side. These four vertical sides, I have not pushed them out to the rectangle yet. So I will still need to count them in my perimeter, right? They are still included in my perimeter. But how long is this? 8? Isn't this the length of the rectangle just now? Yeah, it's 7 cm. So this is 7 cm. Of course, all of these are 7 cm. So I will need to add up 4 times 7 or 7 times 4. They all mean the same amount, right? So this is the actual perimeter of the figure. 8 plus 9 times 2 for the rectangle that we pushed out, plus the extra sides because they are still counted as the perimeter of the figure. They are counted as part of the perimeter. With that, right, the pink part, the perimeter of the rectangle is 34. The total length of the extra sides is 28. 34 plus 28 is 62 cm. So that is the perimeter of the figure, the line E. Okay, not 68, almost there, almost there. 34 plus 28, it is 62. Right? Some people say, oh, this is so hard. Yeah, for push-up method, the key essence here is we want to move around the sides to form more regular figures. But sometimes you might not be moving all the sides. There are still some extra ones that you need to count separately after you form to the complete figure. All right? Or rather the regular shape. After you form the regular shape, look for extra sides. All right? So that's it for question 25. Okay, given that we still have 2 minutes, I would like to go through one more question, which is question 13, right? Some of you also got it wrong. So I would go through this as well, right? Tips and tricks in multiplication, right? What is the digit sum of the product? 75 times 16 times 125 times 24. Now, this actually mimics a P2 TASMO question. I believe this is P2 TASMO 2024. It's an MCQ question similar to that. Okay, so how do we do this question? Okay, so 75 times 16 times 125 times 24. You actually don't need to multiply everything directly. You just need to remember there are some multiplication best friend numbers that can help us in our calculation. Right? For example, in addition, we know that we want to add up the best friend pairs to form tens. Right? This is what you always see in question 1 of our sample papers. Hopefully, you get the hang of it and don't get them wrong by now. But in multiplication, there are also some best friend pairs, right? Two numbers multiply together to give me 10, right? What numbers are they? What number times one number is equal to 10? Don't use 1, don't use 10. Okay, yes. 5 times 2 is equal to 10. Very good. Now let's go one step ahead, right? What about something times something is equal to 100? I don't want any zero in. What times what is 100? Very good, right? You got it correct. Yeah, that means you have paid attention to my lesson. Okay, now keep your comments appropriate, please. Yeah, 25 times 4 is 100, right? And there is another best friend pair, even more powerful, right? It gives me 1000, right? What times what is 1000? What times what is 1000? Yes, 125 times 8. So each pair of these numbers are my multiplication best friend pairs because when I multiply them, they will give me full tens, full hundreds, full thousands. And we just see that, right? I have a 125 here already, right? All I need to do is to find an 8. Where can you find an 8? I don't see any 8s here, right? But we can split a number into its smaller factors to create best friend pairs, right? For example, look at this 24. I can split this 24 into 8 times 3, right? Then we just see that I would have found 125 times 8, which will be 1000, right? So it's easy. Okay, 125 times 8, easy, 1000. Then I'm just left out with a times 3. But then on the left, I still have 75 times 16. Right. Can you find another pair of best friend pairs here? Really, you can, right? Some of you already said, yeah, 25 times 4, but where is my 25? It is here, right? 75 can be split into 3 and 25. I have a 25. Where is my 4? My 4 is in the 16, right? 16 can you split into 4 times 4? And then you see 25 times 4 is equal to 100. So I have formed 100 and 1000, right? So all we need to do now is to multiply the remaining numbers together. 100 times 1000. And then don't just stop there. You still have your 3 times 4 times 3, right? The remaining numbers below. So 3 times 4 times 3 is equal to, let me write that. 3 times 4 times 3 is equal to 36. So this one will be equal to 36 times 100, add 2 zeros, times 1000, add 3 zeros, right? So this is my product. And then the question is asking what is the digit sum. Some of you might fall into the trap and choose E, right? Because you see, others are 0, I don't need to care about it, right? I don't need to care. 0, it doesn't contribute to my sum. So my answer is 36. No, right? It is asking for my digit sum. So at the end, you will still need to sum up the digits. Of course, you don't need to care about the zeros, but 3 plus 6 is equal to 9. So my answer is B. All right, so that is how you can do this question. And now you know whenever this comes up in, I don't know, P3 TASMO or P2 TASMO, okay, then you know how to do this, right? Use the best friend pairs in multiplication. Okay, if you use different methods, okay, good, also can, right? As long as you split correctly, you get the correct answer, that's good enough. All right, so yeah, we have gone through 10 challenging problems in today's live stream, and that's all for today. I will share the solutions in the group chat later. If you still have any questions, reach out to me or ask that in the group chat, right? Our teachers will be more than happier to answer you. And then, most importantly, other than sending out the full solutions, I have noted that throughout the 5 papers, there are some common topics that everyone found challenging, right? Calendar problems, what snail climbs well, okay, addition and multiplication principle, counting, right? These challenging topics, teacher Yonglam has compiled 20 questions in total, right? And I will release it in the form of a rescue kit later, right? These will include more questions for you to practice on these challenging topics, right? I would highly recommend you to do it, okay? Must do, must do. Okay, and then I will share the solutions maybe some days later. Okay, but this one, please remember to try it out. Okay, this will definitely help a lot in your learning. Okay, and with that, that is the end of the day. Thank you so much for your active participation as usual, right? And hopefully you can continuously improve and get a good score in TASMO. All right, that's all for today. See you. You don't understand question 14. Oh, question 14, where do you not understand? Basically, you just need to draw out the calendar and then you consider all the possible number of days, right? Well, it could be 28 days. If it could be 28 days, then what is the last day of this month? What is the first day of next month? Okay, then similarly, 29, 30, 31. Try out one by one. You need to consider cases, right? This is indeed not that direct. Yeah. I need to consider cases. But here, I think the point that I want to get across is if the question describes a certain month, draw out the calendar, right? Don't just think in your mind. Draw it out, visualize it. All right. Okay, any other questions? Why is it D? Now you see, if your month has 28, 31, 30, 29 days, it also couldn't have the last day be Monday. So D is impossible. Okay. Oh, for those who join late, it's okay. You have the playback for later. Okay. Right. So that you. Okay, and then done.